Hi, and welcome to question 13 of the 2024 Junior Cert Higher Level Maths paper. So question 13 is the last question in this year's paper. And let's read through. Michael is designing the roof of a house. The width of the roof is 6.1 meters, and we see that represented on the diagram below. The roof will be in the shape of a right angle triangle of height h. Okay, they show that here, where h is an element of R. Now that doesn't matter, it just means h could be any number, so it's not really that important in the scheme of things. Michael can choose different values for h. The diagram below shows one possible design for the roof, and not to scale, and they're saying calculate the slant height x of the roof in this design, correct the two decimal places. Now straight away I see that's a right angle triangle, and when I see a right angle triangle, it triggers a memory that it's either Pythagoras or the sine cos tan ratios. Now the sine cos tan ratios involve angles. There's no angles mentioned here, so you can exclude them, and it should be hopefully fairly straightforward to realize this is Pythagoras. I'll have the answer done on the next page. Okay, so there's the formula for Pythagoras. Now the C value is the longest side, or the side across in the right angle. So in this case, that's x. The other two sides doesn't really matter. I've called this A and this B. So I've swapped the 2.84 instead of A in brackets. Now it doesn't really matter because it's positive, but just for consistency. I've put the 6.1 value in for B. Then now what I've done here, instead of just going and working that out, I've said I'm going to leave that and do it in the calculator later on. So I realized that I want x on its own. So to get rid of the square, I square root x squared. Doing anything opposite to something will cancel it. But I'm only okay if I do that same operation to everything on the far side. So that's where this big square root appeared from. Now on the next line, the x is on its own, and this big thing can be put in the calculator, and I got a number 6.7287. But the question says correct to two decimal places, so the 8 here is what matters. 8 is bigger than 5, so the number before it goes up by 1 to 6.73. I probably should have put units in there. Yeah, I should have put units in there. I must go back and fix that. Okay, so that's part A. Now part B says the diagram below shows a different design for this part of the roof, and again, not to scale. Use trigonometry, okay, to work out the size of the angle theta in the diagram. Give your answer in degrees, correct to the nearest degree. Okay, so let's clear off the writing. So again, the same triangle, just slightly different dimensions, but it's a right angle triangle. So it could be Pythagoras, okay, or the sine cos tan ratios. So when we relate the opposite sides of the hypotenuse, that's called sine. The relationship between the adjacent and the hypotenuse is the cosine, and the tan relationship is opposite over adjacent. And that's all they are, relationships between angles and sides, and it's predictable in a right angle triangle, or more predictable. So the right angle denotes the hypotenuse. The angle we're looking for, the side opposite it, is called the opposite, and the adjacent is, for lack of a better word, the other side. So Pythagoras won't help us here because it won't find an angle, it'll find a side. So we could use Pythagoras to find the hypotenuse and then work on from there. But if we pick from these formulas, we can use information we already have instead of having to do more work. So I have the opposite and the adjacent. So let's go through it. I'm looking for the angle. Okay. I have the opposite, but I don't have the hypotenuse. Now I could find it using Pythagoras and then use sine, but that's more work. So let's keep going. In the cosine, I'm looking for the angle. I have the adjacent, but again, don't have the hypotenuse. Whereas with tan, I'm looking for the angle. I have the opposite. I have the adjacent. So tan seems to be my strategy. So tan of an angle relates the opposite, which is 3.12 over 6.1. Now in the calculator, the way to find what the angle is to bring tan over And when you bring anything across the equal, you get the opposite on the far side. So inverse tan. So the inverse tan of that number, okay, now for the calculator work, hopefully the calculator would expand for me. So on my second function, I get tan inverse of the fraction 3.12 over 6.1. Just double checking that I've input things correctly. So I got 27.088. So it's equal to 27.088. And it's the correct nearest degree. So none of these digits matter. This is what matters. And that's closest to 27 degrees, which makes me sus. Now I've just realized my answer in my notes is completely arseways, and I've realized the reason is I used the figure from the first part, which is a different triangle. So my answer here is slightly off because the original triangle had a slightly lower height or greater height, whichever one it was. So this entire strategy is the correct strategy, but based on wrong information. So the answer here is the right one. I should have used tan and not the wrong figure of the hypotenuse. Anyway, my problem for not reading the question properly when I initially made the notes. So 13C part 1 says a different part of the roof is in the shape of an isosceles triangle with a base of 14 meters. So big isosceles triangle and then base of 14. Now in isosceles triangle, these angles would be of equal size. Okay. Yeah, okay. So they're telling us that for a reason. In this part of the roof, Michael makes an attic room by putting in two vertical sidewalls here. Okay. AB and DC, shown in the diagram, and again, not to scale. The distance from B to C is 8 meters. Okay, right. The total height of the roof is Y meters. Okay, and AB equals to DC, and they're calling them X. Okay, so C part 1 says use similar triangles to show that X is equal to 3Y over 7. Now, if you see this here, there's a big triangle here, okay? And then let's try to be fancy with the pens. There's a smaller triangle there. So we're looking here at comparing those two right angle triangles, okay? And we can compare them along two different perspectives. So we can go, well, the y over x, okay, compare those two sides, okay, and relate them to the other two sides, which this big long side here is 14 divided by 2, which is 7. And this one here is, now it's 7. This is 4 from here to here. Okay, what's left here is 7. Take away the 4, which is 3. Okay, now let's see, how would this work? So just the algebra of it, okay, I'm going to change back to a nicer pen color. I want to get rid of this 3, so I'm going to multiply the top by 3. If I do it to one side, I have to do it to the other. Now what's going to happen here is y times 3 is 3y over x is equal to this 3 and this 3 will cancel. So we're left with 7 on its own. Now, same way, I want to get rid of the x. Okay, I'm going to multiply top here by x. Okay, and if I do it to one side, I have to do it to both sides. I'm going to end up with 3y. Now the x here and the x here will cancel. Is equal to 7 times x is 7x. Now I want the x on its own, so I'm going to come back at this and I'm going to divide by the 7 to get rid of it. Do it to one side, have to do it to both. And that's going to happen. I'll be left with x is equal to 3y over 7. So there's a lot going on there. But the biggest thing was to realize if they are similar triangles, they're not the same, but they have the same angles. So they're going to share this angle here. Okay, they share a 90 degree. Okay, and then they're going to have to, by definition, share this angle here. So they're similar triangles, but their sides are of different lengths, which is why they're not congruent. And then you can relate those sides. So the y with the x, okay, and relate that to this longer section here with this shorter section here. Okay, hopefully that comes across on the video. And that's it. Now C part 1. Now C part 2 says the area of the shaded region ABCDE, so this shaded region here, is 12 meters squared. Use your answer from part C1 or otherwise work out the value of y. So our answer from C part 1 was 3y over 7 is equal to x. Let's write that down and see where it leads. Now, in essence here, we have, in this shape, we have two different things going on. And let's try illustrate that. We have a big long rectangle here, okay, and then we have a triangle up top. So if we can find the area of the rectangle plus the area of the triangle, that should equal 12 meters squared. Now the area of the rectangle is 8 times x, okay, 8 times x, plus the area of the triangle on top, it's a half base by height, so a half, now the base there is 8 times the height is y minus x. So it's y, take away the x part, gives you this part up here. So that's where the y minus x comes from. So now we move on from that, and we'll try simplify it. So okay, 8 by x can be easier described as 8x. Now this bit here, I just realized I probably should have put that in brackets. Okay, is equal to a half times 8 is 4 times y minus x is equal to 12. And then we can group them. 8x plus 4 times y is 4y. 4 times minus x is minus 4x is equal to 12. Now they can be combined together. 8x minus 4x is 4x plus 4y is equal to 12. I can divide everything by 4 to make it simpler. Okay, and be left with x plus y is equal to 3. Now we know that x is 3y plus 7. I'm running out of space. So I can swap it out. 3y over 7 plus y is equal to 3. Now I'm going to have to combine them together. I could do that by turning this into 3y over 7 plus 7y over 7. Okay, that's the same thing is equal to 3, but they have a denominator now. So it's 10y over 7. And we'll come up here. 10y over 7 is equal to 3. Now I multiply the 7 across. 10y is equal to 3 sevenths is 21. Now I've run out of space again, but if I divide both sides by 10, okay, 21 over 10, I'm going to end up with this figure here. The 10s will cancel. Y is equal to 21 over 10. Now don't be me. This is very disorganized. I appreciate that. So apologies for those who that will wreck their heads. It's wrecking my head. But again, this is problem solving. Okay. So the initial statement there, I suppose let's go to the answer here, of creating the structure, breaking it down into smaller chunks. Okay. writing that on the page so the examiner can see it, okay? And then trying to describe it algebraically. Even if your attempt is crude, that may be penalized, but if you keep going from there, you may get to an answer that may have more merit than you think. But realizing that that strange thing there where this y value, you didn't know it directly, but you did know this height here, because you can, the y, take away the little bit here, take away the x. That was the big trick here. Once we were here, just remove the brackets, simplify, and then you have to remember that you did have a value of x. This is an equation of two unknowns, but you had more information about x, so you swapped it out, okay, and we ended up with a statement of one unknown, which is solvable. It's just a matter of going ahead and doing it. Now I did it a little bit different way. I didn't actually simplify this. That's why it looks slightly different. It made life harder for myself in the notes. And then once we simplify that out, it's just a matter of keeping going with the algebra. We end up with a value of y. Now it's not clean, okay, which would give me some trepidation, but it is still a value, okay, and that's it. Okay, so that's the end of question 13. As always, if you want to copy the notes I'm working off, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists.